Guys, this is Mr. Kidle and we're going to talk about graphing linear inequalities. So let's start by finding if 2 and 3 is a solution for the linear inequality y is less or equal to 3x minus 5. We will label x as 2, y as 3. We're going to plug these numbers in to our inequality. So we'll have 3 is less or equal to 3 times 2 minus 5, which makes it 3 is less or equal to 5 minus 6 minus 5. 3 is less or equal to 1 is false. So the answer to the question is no. To graph linear inequalities, we will first graph the line y equals mx plus b. Then we're going to dash the line for the signs less than or greater than, because that means we're not going to have the line as a solution. And for testing value, we're going to use 0 and 0. So let's do an example. We have the equation y is less than 2 divided by 5x plus 1. To graph this, we know the slope is 2 divided by 5, and then we know the y-intercept would be the value 0 and 1. So let's plot the point 0 and 1 on the graph. Using the slope, we will go up 2 units and we will go right 5. So from this point 2 units up, 1, 2, 3, 4, 5 over. Now when we graph this line, we can notice that the sign is less than, therefore my line is going to be dashed. So it's not going to be a solid line, it's actually going to be a dashed line. That means our line is just the barrier, it's not part of the solution. It just tells me where the solution ends or where the solution starts. And for finding out if we have to shade in the top or the bottom, we're going to use the point 0 and 0. So we're going to plug in 0 for x and 0 for y. So the inequality will be 0 is less than 2 divided by 5 multiplied with 0 plus 1. 0 is less than 1, which is true. 0 is less than 1. That means the point 0 and 0 is on the par with the solution. So we're going to hash the bottom under the line. So the solution, the graph of this inequality would be the semiplane under the line up to the line excluding the line. On our second example, we have the equation y is greater than 3x. To graph this linear inequality, we are going to have to graph this using slope-intercept form. That will be the fastest way. So we're going to add a 0 at the end. Slope is going to be 3 and y-intercept will be 0 and 0. So we will start there. 0 and 0 is the origin right here, and the slope is 3. We'll write that as a fraction 3 over 1. So we'll go up 3 and write 1. It'll be 1, 2, 3 up and write 1. We're going to connect this with a straight line, and we're in the same situation as the one at the top. Our line will be dashed because 3 and y is greater than 3x means this will be my barrier, will not be part of the solution. Now in this case we can use 0 and 0 as a testing value because 0 and 0 it's a point on the line. So we get to choose another point. Let's choose for instance this point right here. The coordinates for this point is 3 and 3. We can use any point we want to. We don't have to choose a specific point, but let's choose this one, 3 and 3. Let's plug in x equals 3, y equals 3. So we will have 3 is greater than 3 times 3. 3 is greater than 9 is false. Therefore, we chose a point in the wrong semiplane. So our solution would be the semiplane over the line, and it will stop at the line y equals 3x. Thank you and have a wonderful day.